equals warrior next step dot to dot board dot get position. Oh, this API is not good. Get position of square. Oh right, this is the way. Board dot get position of square warrior next step. There's some room for improvement here for sure. That is you to find when you do Rust. Okay. C is widely used compared to Rust. Yeah, okay. Makes sense. I mean, it's much more, obviously much more, let's say, established than Rust. It has had a lot more time to become like a standard thing. And then let's do assert true. Warrior next step position equals new position 1 0 or one 1. I feel right now that I'm committing so many sins in programming style and cannot be applied. Oh, I forgot the parenthesis there. C beats Rust or C++ beats Java or anything else. Yeah, that's your point of view. I guess it depends on what you want to do, right? Ah, learning sequence. Got it, got it. Yeah, I remember when I was a kid, I bought a book on C++, and that taught me about how numbers were stored in a computer with like bits representing the numbers, and that basically everything in a computer is stored like that, even letters, and yes, everything is represented in that way, and then you just abstract on top of it. So let's make this work. So we give a position. Or do we need a direction? No, let's use our 2D board visualization again. What is actually interesting to know from this perspective? It's like which direction you want to go. You want to compare your vector of like 1, 1 and you wanna, your direction will be another vector with one step. So the direction here would be -0, -1. That's the direction. Position. Direction. If you really want to do a deep dive into inner working of system, you should do assembly once in a life. Yeah, I know. I should do that. I've been looking some at assembly, but it's too complicated. But I guess for now, like it's not in the Goldilocks zone. Let's say it's a bit too much new stuff. But I'm sure like the more you code, the more you learn about different languages and so on, the closer or like the more ready you would become to consume and to learn about that kind of stuff. So I'm actually considering scrapping a bit of the data structure now because it just feels too convoluted. Like there's a square, and that square is its own class, and it doesn't know its position even. Like, what is a position? Should there just be a like a net? If we begin in 2 dimensions, there should just be points in 2 dimensions. Doesn't have to be squares. But the initial point of the game was to make a board, to make it a bit more simplistic. And then you can have characters occupying those squares. Use a matrix. Yeah. Then you can have sparse matrix. What's a sparse matrix? Matrices that contain mostly 0 values are called sparse, distinct from matrices where most of the values are non-zero, called dense. Sparse matrix obtained when solving a finite element problem in 2 dimensions. The non-zero elements are shown in black. So like the default values would be zeros, I guess. Okay, let's for now use the square analogy. We can refactor later. Return. Wait, how will I return the right square for this test to make it pass? Maybe making this pass being very difficult is a testament that my class is too complicated. You can store matrix in a 1D array, and then choosing row or column major access pattern. Yeah, that's kind of how I have it now. So I have a board, and the board contains squares, and they are stored in a 1D array of the size width times height. And then I get square at position by doing get index of position, which returns me the width times y of the position, and then plus x. So I already have that fixed or done. Actually, but it's just like what I was thinking about was whether I actually need to have like an object called a square or not. And just like traversing the object seems to be pretty complicated. So how do I even return the, let's say, square to the north of me, let's say, or to the west? So there is an owner, pawn type, and square. So I need to traverse to the square. Square can have some meta info about its position or construct square when using getter, but store a very simple matrix. Yeah. Yeah, right now, square has a link to the board, so I can go into the board from the square and then ask the square or the board where in the matrix that square is located. So the upside with that solution is that I only store the position in one place. If I would have this metadata thing that you mentioned, that also has its pros, but then I would store the information twice. So I think what I can do is like square get board. Dot get square at position. Yeah, I think this is how I need to traverse it for now. U position. But querying means searching the board, right? Yeah, it means searching the board, that's true. So I have less, I store less information, but it becomes more CPU intensive. Good point. And it's also more complicated to code it, I think, this way. 1, 0. This should return true in our test. Yeah, it's an interesting perspective. I like how I'm getting closer to these kind of questions. Maybe a next interesting project could be writing some math functions in like, yeah, matrix multiplication or something in C. Okay, what happens if we run the new test now? I'm expecting it to actually succeed. Yeah, it succeeds. So now we need to refactor this. Hmm. Within a loop, search will start to pop off. So the question you have to answer, do I increase the computation or space? Yeah. Exactly. That's something I want to get into in this project also, like performance optimization at some point, and like having some good like recurring measurement. So let's say I make a code change and I have this kind of a test similar to this test driven development things, but like continuous checks on the performance, like how many nanoseconds or milliseconds does it take to perform this test and that test and so on. Hmm. Find path to closest enemy. Yeah, so that's what we need here. Next step towards enemy. All of these concepts are new to me. It's like, how do I write this in a good way? A test. So we have the next step. But we have no way to generate it, and generating it is a huge leap. And I don't want to make a too huge leap in this TDD thing. Other way to mitigate this problem, you can cache the squares inside the board in a hash map, but there will still be some performance hit. Yeah, that's a very good point. I was thinking about that too, that at some point I should have a lookup table instead of looping through the array. Hmm. So okay, let's start adding some made up methods here, or these methods that we have started working on. Find path to closest enemy. LRU cache. Least recently used. Interesting. Ah, yeah, that's really interesting. So you could have some smaller cache you can look in. Ah, it's an interesting concept. So like a LRU cache for the hash map, for example. So you check there first, and if you don't find it there, you check in the bigger hash map. Is that how it works? Yeah, that's cool. Right, this one didn't have all the stuff it needed. That one neither. Find path to closest enemy. Path to closest enemy equals, yeah. And then I want a square here. Square. Square next step equals path to closest enemy dot get next step. Okay, so we have a few things here that we need to populate or create methods for. Get next step. Path. So I should probably write a test for that, right? Path. Start with a test. So get next step. Path.get next step. Test for path. Get next step. Test. There is no bigger cache. When you search, put the results in LRU, but least used will be removed from cache since the probability of using it is very small. So the LRU will only have high hit squares only. Yeah. That's a really good point. So like if you have a game and there's like a heat map, let's say, where there's a lot of activity, a lot of stuff going on, but maybe there's some like corners or some areas that for some reason are not touched a lot. It wouldn't make sense to spend time cycling through them every time you're doing stuff or like looking something up. You just go through the ones that you use the most. That's really smart. Huh. So on this test, we have a path, new path equals new path. And that has a square in it. So we need two squares. Square 1 equals new square. So that doesn't even work. Do I need a... Oh, I need a board. Okay, let's just use a board here. here as well. Board equals new board. Square 1 equals board.get square at position 0, 1 on new position. I think newer Java has var keyword. Really? What does that do? I'm actually using, I think, the latest JDK, like 21, version 21 or something. Square 2 equals board.get square at position new position 0, 2. So let us now create a path with these 2. Var my int. Oh, what? Really? That's so it's like not type statically typed. What? Why would they introduce something like that? Feels so un-Java-like. Let's try var square 2 equals new board square 3. Yeah. Type inference. Yeah. So it guesses it or what? Yeah. But that definitely has its downsides. I thought one of the good things about Java is that you need to be specific so that you can catch issues earlier or like at compile time rather than at runtime. Okay, then we have new path equals new path of square 1. And then we have another new path of that path. And square 2. So I think how this works now is that square 2 would be come in at the end of that path. Yeah, that must be the case. I mean, we're designing it now. Can kind of decide. You can still provide type with var, I think. Okay. Then what's the point of var? Path dot get a next step. Assert equals path dot get next step. Oh, what happened now? It froze for a while. It's too big program here. The computer cannot handle it. Comes handy when you're giving same type twice, like with new keyword and declaration type. Ah, got it. So, okay, yeah. So instead of writing like board, you just like var board, new board. Yeah. True. Good point. path get next step should equal square 1. Let's do dot get position. We don't have get position on the square. We should create that. But for now, let's do board dot get position. No, they should actually be the same square, right? Path get next step should be equal. Should be the same object. Yeah. So path get next step. Cannot find symbol, scan paths for enemy, get next step. So test is written, but it doesn't compile yet, so get next step method, scan paths for enemy. Path, sure, return null for now. Get next step, cannot find symbol. Yeah, so that's what we need to create now. Public square. Public square. Get next step. Return null. I just wanted to compile. Okay, nice. So it is compiling. Now let's fix it. Should just take whatever is at the start of that linked list of squares, I think. Return squares 0. This dot. Why does that not work? And this should not be public, but let's fix that later. Array type expected. Get first. Okay. Nice. Get next step. What happens then? Array list for each. Get first. Get next step. Not really sure. Get first. So what are we dealing with here, really? Path. Could you check if the JetBrain is providing at nullable? If it does, use this to force check null on the call side. What do you mean by that, at nullable? So would I do that on a method? So like on path, I would give, let's say here, at nullable. Doesn't seem like it has it from by default at least. No such element. Okay, what if I do it really simple and just do one path first? Then it's only available to Android Studio. Okay. Okay, this passes. Actually. So I can either create a new path or I can add on to a path. And what happens here? Nothing happens here. That's probably why, yeah, that's why we had a problem there. So get squares. Yeah, that's why it didn't work. I hadn't implemented it. So here we get a path and then we get a square. So we need to create yet another method. And to follow test-driven development, ideally we should actually create a new test now to test this path creation. Let's do it. Because otherwise there's going to be just too much to hold in our heads. Void create path with path and square. So it's basically going to be the same test in the beginning. We can do that. Throw unsupported operation exception in the empty function body. This will tell you that function is not implemented or any exception you like. Ah, interesting. That's a good idea. Throw. How do I throw? There's so much to learn. Ah, okay. Throw new exception not implemented. No? This doesn't throw. Okay. Throw. Oh, yes, yes, I need to add it. Okay, now I know. Public path and then throws. Right? And then throw. No? Is it now can I do that? No? Okay, now. That should do it. Yeah. That does it. Cool. Right. Okay, so I'm actually gonna take a little break here. But thank you so much for coming in and hanging out on this coding journey. It was a pleasure to have you here and talk and code together. So thank you so much for that. Remember to remove throws after implementation. Yeah, I guess that's the downside of this, to have like many throws lying around. But as with a lot of stuff in this world, I think there's so like pros and cons with most choices. Yeah. All right. Thank you so much for tuning in, and for everyone watching on YouTube. Also, thank you for making it to the end of the video, and I hope to see you in the next one. Cheers.